and how to use it effectively. Right, so I'm going to start. So to illustrate a lot of things, I'm going to need to pretend that I have other people on my team. So what I'm going to do is I'm going to have a left person and a right person and a left person. So left person is right person is like the normal lecture player that we've been doing in the Battlecode scaffold one, and right person is going to be have a different name, or left person. Oh my gosh, left person. All right, so this bot that I just created will not work because the folder name left person does not match the package name, which would be lecture player still. Yeah.
On the right hand, if you could move up the green bar, that way your face when we're watching it on Twitch will be.
Oh, my face isn't on Twitch anymore because that was slow and you don't need to see my face.
Okay.
So.
It'll be up on YouTube. I mean, when they look at it on YouTube, like it'll be obscured.
Or wait, no.
Your face is on the bottom right hand corner.
Yeah, my face isn't being overlaid anymore. I turned that off because it didn't add anything and it was slow. Yeah. All right. Anyways, so left person isn't going to work, but I'm going to use them as an example for all this Git stuff. So let's go in there, and then tmux is just a window manager, but I don't like that theme. I don't like that theme either. This theme's fine. All right. All right. So we have left person, and we have the regular lecture player. Great. All right. So these are two completely separate copies of the code, as if it were me on the right and one of my teammates on the left. And so that's how we're going to cause lots of conflicts and stuff. But first, because I've been getting really tired of typing out like git status and git log and stuff like that, I'm going to show you how to do git aliases. So there's a cool file, a very cool file called git config, located here. And this can have things such as aliases, which is this line, and all of these are all aliases. And so what those let me do, I'll just show a couple of examples. So S is alias to status, P is alias to pull, CO is alias to checkout. So for example, I can say now, since I have those files there, I can do git S, and it's the same as git status. I can do git P, and it's the same as git pull. Amazing. I can do git CO, and it's auto-completing me. I need a branch. Testing? Is there a testing branch? So I did git CO testing. There's no testing branch, so that doesn't work. If I wanted to create a testing branch, there's another alias, COB, which does git checkout with the -b command. And so -b is a convenient way to create a new branch and check it out. There's also a command, a git branch command. Sorry, so I only typed git branch, and this shows me which branches I have. I can delete branches, so the self-defense branch has been merged into master, so I can do git branch -d self-defense, and my editor, okay, there we go. So that's what I actually typed, git branch -d self-defense, and it deleted that branch. You may have noticed that I didn't type out self-defense all the way, because Git has autocomplete. So if I say git, oh my goodness, this autocomplete is killer. Okay. Maybe I should just turn it off. Okay, I'm gonna turn it off. Give me a second. ZSHRC. Complete. All right, well, maybe so I'm using another tool that I was going to show you. All right, so I'll just show you now. There's this thing called OhMyZSH, which is an alternative to Bash. So Bash looks like this, and it's kind of boring. as opposed to oh my ZSH, which can look like this, or it can look like this is another random theme, this is another random theme, this is the same random theme. Whoops, I don't want that. So oh my ZSH is a skin and a sort of plugin system for ZSH, and you can have all these nice things, nice themes and other plugins and stuff. So I would highly recommend getting that. It's cool, and you can have more colors. It'll also make your terminal command history look funny if it breaks to a new line because there's a bug. So I'm just going to make this a little wider for a minute. Okay, so git branch, what I was trying to show you is git branch lists the branches. Git branch -d deleted the thing. Git has autocomplete, so if I say git checkout m tab, it completes to master, which is amazing. This is similar to normal bash where I can say ls capital R and then hit tab, and it tells me, oh, you have all these options. So I could do re tab, and then it's, oh, just readme and refinery. Ref tab, autocompletes refinery. So that's great. Git also does that thing. Anyhow, we have branches and some aliases. So again, those aliases are in git config. Actually, I'll keep that wide because it's going to keep getting annoying. These are in git config, and I'm going to put a copy of this config in lecture player so that you can copy them if you would like. My favorite one is C, which does all of the things that I would want for a commit. So what we've been doing is git commit -am. There are two ways to do aliases. So one is just a replacement. So when I do git r, it will do git rebase and then whatever. Like it'll replace that in the command and then execute the full command. If you start the alias with an exclamation point, then it takes the first half of the command, which would be git c, removes it entirely, and replaces it with this, git add -a and then git commit -m. So the way that I use that is like git gc add space. So this is a commit that I made earlier today. And so what this will do is git add everything, git commit -m, and then the quotes are the message for the -m. So that's what these are, and that's pretty much all I'll be using. Git lol is the sort of like nicer looking log. So we have git log, which looks like this, and we have git lol, which looks like this. It has like branches and stuff, which is like kind of cool. So yeah, so that's what those are, and I'm going to be putting that. The other thing is, I slipped up a second ago and did gc add space instead of git c add like empty list is true or something like that. And this is because I have also aliased git to g, because those two characters are really a pain to type. And the way that you do this is not with git. You do this with whatever bash you're using. So normally, if you're just using bash, you would edit bash rc. Since I'm using ZSHRC, or since I'm using ZSH, zero shell, I edit ZSHRC, and I have a bunch of aliases down at the bottom here. And the one that we care about is G equals this one. So alias G to git. So this means, oh, go away. So this means when I type G now, if I just press enter, that was just G. This is the equivalent of typing, stop that, sorry, typing git. So now I can do GS for git status, GP to git pull, all that good stuff. And I'm going to use those for the rest of the time because it's way fewer characters and therefore better. Okay. Right, so that was the first thing. There's going to be a document that looks like this that has like all of the stuff that I just said because I said it really fast. So here's the alias and the git config and stuff. And I'm going to put this in lecture player. The other thing is SSH. So I haven't had to, if you just cloned lecture player ever or the scaffold or anything and you used HTTPS, so it looked like this, then you had to, you may have had to type in your GitHub username and password. That's also more typing than you need to do. So there's this thing called SSH, which stands for Secure Shell. And you can use SSH instead of, or for authentication, instead of using or typing in your username and password over HTTP. So the way that this works, there's again, the README here, or not the README, the markdown here that I'm going to put in lecture player has the link to set this up with GitHub. It's very straightforward. Just copy and paste their commands blindly, and you'll be fine. But the high-level overview of what SSH does is you generate a secret key locally on your own computer, and this is like not a thing that only Git uses. You can use this for lots of other things. So like if you want to SSH to another computer, which is to get a secure shell on another computer, you could authenticate by typing in your username and password. So for example, I have a desktop that I call HQ, and I can type in my username and password because I haven't set up SSH, or I could SSH to this one, which I have set up with automatic sort of like I've set up SSH keys between these two computers, mine and this server, and so I didn't have to type in a password, and so that's great. So SSH, the way that this magic happens is you have a private key on your computer that you generate as part of the process, and then you copy and paste the public key into GitHub, and you sign in and stuff and say, oh yeah, this is a public key that belongs to me. Same thing with SSHing to a remote server. And then GitHub, now instead of, when you send a request to GitHub, which is like, oh, give me this repository, please, instead of saying, oh, what's your username and password, GitHub will say, please sign this message to prove that you control the private key that belongs to the public key that I know you have, that you told me about earlier. So when I just did git clone, where was it? Git clone, git at blah, 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 that did exactly that, where my computer contacted github.com, said like, please give me this Git repo. Because I'm using SSH, it's git at instead of http:// blah, blah, blah. GitHub was like, please sign a message that confirms who you are. My computer automatically signed it with my private key, sent it back to GitHub. GitHub can check with my public key that I am indeed that signature matches. And then they know that like the computer that they're talking to is actually me. So like at a high level, that's what's going on with SSH. And that makes it so you never have to type in your username and password again, which is great. Okay. All right, so that was a lot of setup for actually using Git commands. But an important setup because now I can type short things and not type in passwords. So great. The first thing that we want to do is to build only 5 miners, I think, because as we saw in the sprint tournament, resources are not always easy to get, and so we probably are building too many miners with 10. So let's just make that simple change. We'll go here. This is, let me make Sublime half the screen. Come on, Sublime. All right, fine. Have it your way. Oh no. Okay. So. Right, so this is right person, this is lecture player, not left person. So let's open up miner, and we can change, where's the 10? Oh, the HQ is the one that builds miners. I'm a fool. Okay. So we build 10 miners, so let's just change this to 5 miners, and then we can go back here and say get status, great, git commit, I know, don't worry, only 5 miners. And then great, so we've done that. And so we made this commit. and we pushed it so that someone else can get it. So now left person is going to pull. Oh, I said I wouldn't type that. Okay, so now left person is going to pull. Great, they have our new change. If the left person does git log, they'll see only 5 minors. Fantastic. Although, maybe we should have tested that before we just went ahead and pushed it, right? So let's see what happens. And we'll go to infinity. Oh, it's left person drat. All right, new plan. Sorry, the thing that I said about packages is messing up the client because it wants to compile left person. Okay, I'm just gonna hide left person for a second. Do I want to edit all of left person's package names? Probably not. Okay, yeah. Well, let's just forget left person for a moment. We'll reclone them in a second, but I want the client to run. Okay, great. So we're building way more than 5 minors. What the heck? It's because I accidentally made a typo and it's 50, but left person has already gotten my change. So like what do I do? I made this terrible mistake. So there are a couple of options. So if we look at the log, we can see, all right, so this is the most recent commit. If I want to look at an earlier version of the code, so maybe I made a much more complicated change and I want to see, and I just noticed a bug, right? So I want to see, is this bug because of the commit that I just made? All right, we'll use Git Checkout. So we'll check out the second to last commit. So head is where Git is currently pointing in the commit history. So if we look at git log, it says head is here at mass. So like this is the commit hash, and so like a unique identifier for the commit. And it says that head is pointing to this hash, master is pointing to this hash, origin master is pointing to this hash, and origin head is all at this hash, which is great. But what we could do is we could check out the last commit. So head minus, I say minus, but it's a tilde. So head -1. We are now at, okay, so it says we're in detached head state. We can look around, make some changes, but if we try to like change anything, it's not going to work because we've sort of rewinded history, and you can't go back and edit history yet. So if you really wanted to like make some changes starting from this, you would now have to create a new branch, as it says. So if I created a new branch right now, it would branch off of the commit we're currently on, which is the one remove unused. So right now, see, it doesn't say that master is here anymore. This is just head, where it's detached head. If I get lol, I think it'll show me. Yeah, so master and origin master and all that are still up at this, the most recent commit that's like actually synced everywhere, and head is detached down here, one commit behind. So if we branched now, we would make a branch off of this commit. That branch would not have the only 5 minors commit, and then we could make some other changes and merge it back in later or something. But for now, so we can just run another game and like see if the bug is still there, right? And if the bug is still there, then like our commit didn't make it happen, and if it's not, then this most recent commit is what made it happen. So great. Okay, so once we've looked around some, we can go farther back in history if we want to check maybe it was the commit before that. And so now if I glol, it'll tell me, okay, so head is now back here, and master's still up there. Great. So we can look around some. We can even make changes and stuff. So if I go here, this is the state of HQ later. We could make this a 1, and then if I do git status, it'll say, oh hey, you modified this stuff. By the way, head is detached, so like, be careful with what you're doing here. And so like maybe I make some changes, determine that the bug isn't at this commit, and then what? I don't want to like go back and undo all the changes. So anytime you have changes that you just kind of want to throw away, and they haven't been committed yet, that's sort of the easiest state to be in. Oh my goodness gracious. Why are you like this? Sorry, my computer is just going very slow. I thought I was typing in a window that I wasn't. All right, like I said, changes that we don't want. So I have all these changes that I was making while I was exploring or whatever. So one handy commit command is git checkout --dot, which throws away all uncommitted changes. So right now I have like this thing that's modified. I don't want those changes. I haven't committed them. Nobody else knows about them. They're super easy. I just throw them out like this. And now if I say git status, I'm back in my original detached head state. HQ still has a 10 here because I threw away those changes. And I think the client is making my computer sad, so I'm just going to close it. And so yeah, all those changes were thrown away. We don't have to do any extra cleanup because they weren't committed, they weren't synced, nothing crazy like that. Okay, so great. We want to get back to the original state. We figured out where the bug is. It was our last commit that we made, so that we check out master again to bring head back to where we wanted. So now head is back up with master, origin master, all that good stuff. Okay, so now we're back where we started, and there's still the problem of this last commit. Only 5 minors. We introduced a bug, and we want to undo that. But the problem is that our partner here already has those changes. So we can't just remove the commit, which I'll show you an example of in a bit. We have to use Git Revert. So Git Revert is a command for making a commit that is the inverse of a different commit. So all of the lines that you added, so if I refer to the commit head, which is the most recent one, all of the lines that were added are going to be removed, and all the lines that were removed are going to be added. So it's literally just the opposite of this commit. So I can say git revert head, and the default commit message is revert, and then the old commit message. So I'm going to do that. And now if I say git status, we see, okay, you're ahead of master by 1 commit. We can actually, wait, I want to show you left person first. So we need to go back to that clone now that the client is gone. Let's see, where is it? All right, hold on. Another handy command, Control R in a terminal lets you search backwards. So I can search for clone and find that command that I just run a while ago. All right, anyway, so we have left person again. That's great. Left person, we can look at their current state. They also have all the stuff that we have, head, master, all that good stuff. So now we can git pull, make sure there's nothing else. Git push. All right, so now that revert is on GitHub. The state of the code is back to 10, which is better than 50, even if it's not what we want. So there's no more bug. It's been reverted. Say, just for the sake of argument, that left person has made some changes in the meantime also. So we can just make some unimportant change to robotplayer.java or something like that. So we can just say like just add this. Darn. Okay, so left person has edited robot player. We can use GD for Git Diff to see what the change was. That's a change we definitely need to have in our bot. So we can go ahead and commit it. Lament errors. Okay. So left person has made some changes. This is what their view of the world looks like. Right person has also made some changes, which is reverting this commit. And this is fine. This is exactly how Git is normally supposed to function. Both people have made some changes. They've made some commits. One of them has pushed those changes. Left person hasn't pushed yet, so they need to git pull. We're going to say, oh, you need to merge because there were some commits that you didn't have. So we're like, okay, cool. And now if we git lol, we can see there was a little bit so there were the history of master diverged briefly when left person made this commit and right person made this commit. But now we've like merged those two branches. They're unnamed branches, but they're branches. Branches back together in this one merge commit. Great. Left person or right person still doesn't know about anything left person has done because left person hasn't pushed it. So this is still the state of the world as seen by right person and as seen by GitHub because left person hasn't pushed again. But if left person pulls one more time just to be sure and then pushes, that's great. GitHub's not going to have any problem with that. And now if right person pulls and git lol, they'll see the exact same history. And again, both people are perfectly up to date. And now left person, if we look at left person right here, if we go to the HQ, we'll not have 50 anymore, just 10. So that's what we want. And they're totally in sync. Despite like accidentally pushing this bug, we handled it, it's fine, it just went into sort of the history of master. But this is kind of, it could be better, right? Like we have a lot of extra commits here that we didn't need, and like this is just sort of obfuscating the like history of the project, right? Like we have all these changes, then like sometimes the changes get reverted. Like there are a lot more commits than there need to be, and like it's nice to have these colored lines, but it would be nicer if it was just like sort of one clean history, right? Also, right person had terrible practice not like testing their code or anything before merging it into master, which is like the main thing that like everyone is working off of, right? So you got to be really careful to keep master clean, or like green, as some people say, green being like passing all the tests. So you want to keep master green, and this is not the way to do it. If you wanted to make some changes, what you should do is git checkout branch. So this is again shorthand for git checkout -b, which will create a new branch. So we can say git checkout branch minor improvements. So now we're on a branch minor improvements. We can go back to editing this. We can make it 5 as we intended, and or actually, just for the sake of example, we'll make it 50 again. So it's now 50. We're in a hurry, so we get messed up by the autocomplete again. Okay, so we're in a hurry, so we just commit fewer minors. Great. Okay, and then we and we have to push. Right. So I just created a new branch, and I haven't told GitHub about it yet. Sorry, I'm skipping ahead of myself. When you create a new branch, you have to link it to the remote, because right now master is linked to origin master, which is GitHub's copy of master, and that's great. So that means when I pull, I'm pulling from origin master. When I push, I'm pushing to origin master. But this branch only exists for right person. So left person, if they have git branch, right person only sees master. Left person sees both master and minor improvements. And GitHub, if we refreshed, but I don't want to wait for it, if we refreshed, would only know about master as well. So what we need to do is we need to set the upstream so that this branch knows where to push and pull from. You can do that with this command, or there's a shortcut. You can git push -u. Oh my goodness. So git push -u is, no, it's too long. Oh, great. So git push -u is shorthand for set upstream to. The -u is the upstream stuff. So I can say I want to push to origin and then the name of the branch. So the last time I did this is when I was trying to like do that fancy mirroring thing that kind of failed a little bit and then worked later. So in this case, we want the remote branch to have the same name, minor improvements. I just tab completed again. So that's a fancy trick, I guess. I don't know. But anyway, so we're pushing and setting the upstream at the same time, which is like a fancy way to do it in one command instead of the two. But so now this will say, okay, great. There's created a new remote branch, minor improvements. and it's set to track minor improvements, the local branch. So now those are connected. If I say git pull, it pulls correctly. If I say git push, it pushes correctly. And if we went to GitHub, we would see that branch. So let me make this smaller. Great. And we'll go over here. And so now if we git pull and git branch again, whoops. Oh, right. So it says there's a new branch on origin, but it doesn't by default pull all of those changes. If we want left person to have the changes on this branch, left person needs to check out the branch and then pull. And this is just a lot nicer because then you only need sort of master and like whatever feature you're working on instead of like master and like all of the code that everyone is working on across a 10,000 person company, right? All right, so, but before left person gets those changes, left person is working on other stuff. So they don't, you know, they're just off on their own, doing their own thing. Meanwhile, right person is you know, set on making some minor improvements. And so say now that we've hastily committed, okay, hold on, where am I? I'm lost. Okay, now that we've hastily committed those changes, say we decide to check our work, we realize that there's the bug, it's 50 instead of 5, which is what we wanted. So again, this has already been committed and already pushed to the remote, to origin, GitHub. So right now are we like screwed again? Do we have to make another commit that reverts it and like all that stuff? Not necessarily. So since no one else has this branch, we are free to rewrite history. So there's a command called Git Reset. Sorry. There's Git Reset. So reset has a couple of options. If we just reset normally, so we reset the last commit, or we reset to, so git reset and then the commit that you're resetting to. So if I want to remove the last commit, I do git reset head ~1, which says go back to head ~1, which is 1 commit ago. If I wanted to go 2 commits ago, then I would do 2, etc. But we only want to reset the 1. And so by default, git reset is going to just like totally remove the commit from our commit history, from right player's commit history, or lecture player's commit history. So if we git lol again, we can see that we are now, we're back here. So it knows about this commit, but master and all that stuff. Oh wait, this is even better than I thought it was. We haven't even pushed to master, or we haven't even pushed to GitHub yet. To origin slash, oh wait, no, we have, sorry, origin minor improvements is right here. Okay, so we have pushed our changes, but that's okay. We are currently reset here. So before, when you just check out, head goes back 1 and is detached, but the branch, the reference to the branch itself, minor improvements, would have been back up here at the top commit. Fortunately, reset exists. So now this commit is orphaned and will just sort of disappear if we don't do anything else about it. So we've reset. By default, git reset keeps the changes around. So now it's as if we had edited the file and not committed, which is like exactly what we want, right? So we can say git status, we can git diff. This was the one change that we made. If we look at just the log, we see no evidence of the fewer minors commit, and so this is great. We can fix our bug. We can just remove it entirely. Say we wanted to remove it entirely, we could do git checkout --dot and lose all those changes. There's another variant of git reset. So if we knew we wanted to throw, I'm just going to recommit again, just for show. So what we can do, we're back how we were, kind of mostly. So we have this commit again. If we know that we want to throw away the entire commit, we don't want to just like go back and sort of edit what changes were in it. We want to throw it away entirely. We can git reset. Oh no. Git reset --hard. And so this will do the exact same thing, except it'll throw away all the changes since then. So if we git reset hard, now if we do git status, no changes. It says we're behind origin by 1 commit, which is exactly right because we just deleted that commit. And if we look at our own history, we can see no commit at all. We are back here just like with the soft reset, but there are no changes still staged. And again, that's the equivalent of just git reset, like regular reset, and then git checkout --dot to throw away all the changes. Okay, so great. So our local branch is now in the state that we want, which is without the commit that had the bug. But we have this problem where we were too hasty and we pushed to master, or we pushed to GitHub too early. If we hadn't done that, if we had tested before pushing, then we would be done now. Even if we committed too hastily, we would be done because we hadn't told anyone else in the world about that commit. So if we remove it locally, then it's just gone from the world. But because we pushed already, if I git pull right now, so if I try to push again, GitHub will say no. You are at a later version. At an earlier version than the remote. The remote has some changes that you don't have. Like you don't want to push right now because you're in the past. And if we pull, then we're gonna get that change. So now if we say git log, like dang it, we have the buggy commit again, right? Because remote has it, and remote is like, oh, I have a more recent history than you. Like here you go. Like I'm so gracious. But no, this is a bug. Now we have to git reset again. And so now we're back how we want it to be, but if we try to push, GitHub says, no, you're in the past. So what do? Git push --force. So this is not what I want. Why are you like this? Okay, git push. I know why this is happening. Like I say, I'm trying to figure out how to get around this autocompleter. Usually it's really nice. Okay, we're just gonna do it this way. So git push --force. This is the most dangerous command that I'm going to show you all day. Use it sparingly. And when you use it, be very careful to specify exactly what you're force pushing. Git push force will take what you have, and it'll take what GitHub has, and it'll throw away what GitHub has and just copy what you have. So like if someone else on your team has like made some changes and pushed them, and then you force push over that, the changes will be lost. Like they'll still be on their computer, and it'll be a mess to resolve. But according to the remote, the thing that's supposed to be syncing everybody's changes, the changes will be gone completely, like unrecoverably gone. When you force push, you are overwriting everything. So this is a opportunity where you're rewriting history. And as such, you should always be careful with time travel. Okay, so we're pushing to origin, and the branch that we're pushing is minor improvements. So if you just do git push --force, depending on your defaults, it may try to force push all of the branches, which is bad. I did this once in Course Road. Unfortunately, someone else had a copy of the code that could just like sort of update it with like all the stuff I deleted. But be very careful. Always specify the branches, and always be careful with git push --force. So what this is going to do is it's going to take what's on our branch, minor improvements, and it's going to overwrite whatever is on the origin for minor improvements. And again, I can only do this because no one else has downloaded that commit yet. So just to make our lives difficult, I'm going to make left person do exactly what we don't want. So left person is going to git checkout minor improvements. Okay, so now left person has minor improvements. Left person has all the commits, including the one that we don't want, fewer minors. Okay, so this we're gonna force push with right person. And so now to right person, everything looks okay. So if we get status, it no longer says that we're one commit behind. we can git push, and it says you're fine. And if we git log, it doesn't have the buggy commit. If we go to GitHub and we look at our branches, it says minor improvements is the most recent commit on this branch is the merge. It does not have the buggy commit, but our teammate, left player, or left person, already, oh wait, did I just pull it? I can't tell. Yeah, so left person has the commit that we don't want. So this is a problem. Because the next time left person, so even if left person is on master, or it doesn't matter. So the next time left person, maybe left person does something, whatever, and then they push. And guess what? The buggy commit is back, right? So this is like, okay, now what, right? And so this, like, you may get yourself into this situation a lot if you're not careful, and especially if you have like multiple people working on the same branch at the same time, which is like fine, but this is just stuff to be careful about. Okay, so there are two ways out of this. One is to have left person and right person both revert the commit and force push. And one of them needs to force push the origin, the remote GitHub. That would do it. You could independently edit their histories and whatever. Another way to do it is if left person isn't actually working on that branch, they just like wanted to see what was going on, they wanted to see the minor improvements and stuff, they can go back to master. They can git branch -d for delete minor improvements. GitHub will say, oh, those haven't been merged to master yet. Are you really sure you want to do that? And, oh wait, no, it doesn't say that. It just says, oh, you have unmerged commits, but we deleted it anyways. So yeah, so now it's deleted. Now this person, oh, brash. Now this person left person only knows about master, and if we pull and push and whatever, there won't be any problems. So right person is again the only person that is working off of this branch. So we can do the reset. We can do the reset. We can force push, and now if left person pulls, pushes, and then right person pulls, we have finally gotten rid of the buggy commit. So that's fantastic. That's the worst case scenario for when you've like made a commit and pushed it and someone else has downloaded it. That's sort of the worst case scenario you'll get into. If left person had gone ahead and like made a bunch of changes on top of the buggy commit, that would be worse. And we'll see how to address that in a bit. But that's how you can rewrite history. Again, only ever rewrite history on a branch that no one else cares about, and ideally test everything before you commit it. But at the very least, test everything before you push it. But also, like, it's fine if you're working on your own branch and you're like developing some feature and like you have to go to sleep or something. You can like commit your changes so far and just like push it so that it doesn't get lost if your laptop gets falls down the drain or something. Like you want it to be available just in case. And if you're the only person working on the branch, that's fine to like push a buggy commit. You can always like undo it with another commit or like finish your progress or whatever. And then when you do a pull request or something back into master, that's when you could like do the really thorough testing, because it doesn't make sense to test every commit thoroughly, but it does make sense. Every time something goes into master, you probably want to test that thoroughly so you keep master green. But right, so generally it's easiest to just have like one person per branch. They like are working on their own feature or whatever, and then pull requests into master, and that's when other people will like check it out and like test it themselves and stuff like that. Okay. So we got some minor improvements. Let's go ahead and just make those improvements the right way, just for good here. So now I can see, oh wait, how is it still 50? What the heck? Oh, that's funny. Okay, so this branch does not have, wait a second. Oh. All right, so in my haste, I reverted the previous commit also, which is fine. It's just that it's not on this branch anymore. So this is actually, I did that on purpose. Okay, so if there are some, so now we're in a state where there are some changes on master that you would like to have in your code, on your branch. So what you can do here is you can just say Git Merge Master, and that will pull it in. Oh wait, you have uncommitted changes. Okay, hold on. Let's get rid of those changes for a second. So I'm on some branch. I've been doing some stuff, and there's new stuff on master. So I'll just merge it in. And because of the state that it's in, it was just a fast forward, as in there were no new commits on my side. So I could just pull in all the commits from master, and there didn't even need to be a merge commit. And so now we have all of this stuff on master again. We are back in the state where we introduced the bug, or that's left person. We introduced the bug and then reverted it, so now it's back to 10. We would really like it to be 5. So now that's where we are. We can make a new commit, fewer minors, and test it, and then push it. And so now minor improvements actually has the improvement we want. We can go to GitHub. We can make the pull request and stuff. We can say compare blah, blah, blah. Fewer minors. So we'll create this pull request. Left person, gets the notification or whatever, comes over here, says, oh, hey, what changed? Only 5 minors. Okay, sounds good to me. And then, can I self-review? Maybe. So left person says, all right, I can't approve my own pull requests, but the left person says, looks good to me. And then you go ahead and you merge it into master. Great. And so now right person has some cleanup to do. And I'm also just going to delete the branch so that I don't end up with a lot of old branches lying around. Okay, so it's into master now. Left person, if they pull, we'll see, oh, hey, master has some updates. So we'll go back to master, get those updates. And then it's now since that branch has been merged, it's safe to just go ahead and delete it. And so now we are back in the state that we started in. Branch. We're back in the state that we started in, just with master. We have a bunch of nice changes that have happened since then. And left person can now benefit from all those minor improvements, and is on master and everything. And all right, so now everyone's up to date again, and we have some minor improvements. Okay, so just as a quick recap. All right, so we did this. Only 5 minors, done. Okay, so we've cloned, status, pulled, push, add, commit, branch, checkout, reset, and merge. We'll talk more about merging and rebasing in a second. But okay, so we've seen some ways to sort of manage the Git commit history and stuff like that. Hopefully we're more dexterous now with sort of like making changes and unmaking changes and stuff like that. Does anyone have questions about what I've done so far? All right. Okay, so next As is often the case, especially with Battlecode, when you're like trying to move really fast, you and your teammates may be making changes that affect each other's changes. So, for example, say write person wants to work on making the wall a little bit taller to protect the HQ. So write person is going to make a new branch, Git Checkout branch. I don't know, bigger wall. Okay, so the command was actually Git Checkout branch, bigger wall. Sorry for this autocomplete silliness. I'll just, you know what, I'll keep it. All right, write player is that big. Okay, so we're now on the branch bigger wall. We're just going to do the usual upstream thing. Are you kidding me? Okay, well, whatever. Origin bigger wall. So that the command that I actually just did was this. So now bigger wall is all set up to with the remote and everything. Changes I make here, I can push the remote. Great. So one thing that we can do is we can go to the landscaper, and only having a 40% chance to build the wall versus to like move around the HQ to help make sure the wall is even is probably too low. Really, we want to spend most of our time building the wall and only a little bit of time running around the HQ to make sure that the wall stays even. So we can probably bump this up to like 0.8. And so that's hopefully going to make the wall a lot better. And since we learned from our mistakes, this time we're going to test it. Whoops. Battlecode visualizer. Oh, left person's going to make the visualizer sad again. I wonder if... Let me just try moving this to a different name. I think the client might ignore stuff that starts with a dot. Let's find out. That would be a negative. Okay, hold on. I just need to remove the left person again. So left person doesn't have any interesting changes yet. So I'm just going to do the thing where I delete them again. But this is only because I need the client to run. This is not like a workflow that I recommend. Yeah, so our left person. Okay. All right, so now we can run the client, test our changes, do lecture player, and infinity. Okay, great. So we're running this game, and there's kind of a problem, which is that we're not building any landscapers. And once we eventually do build landscapers, barely any of them even like end up standing on the wall. So it's very hard to test this change as is. Like we need some improvements that left player has been working on in the meantime, which is to fix the bug that made it so that these miners were trapped around the HQ. So if you watched the sprint tournament, you may have heard us noticing that a lot of people on this map, because there's so much soup right near the HQ, their miners would pick up a little bit of soup and then deposit it, and pick up a little bit of soup and deposit it, instead of pick up, deposit a lot. And so some teams would take almost twice as long for their miners to pick up all the initial soup and get out of the way than other teams who did it the pick up lots of soup, deposit lots of soup way. And unfortunately, this is my fault, because in lecture player, that's exactly how it works. So that is what our teammate left person has been working on. Let's just clone again. So ignoring the whole deletion thing, which we can pretend never happened, left person is here. They're on master. They're in the state that we left them in. But they are working on their own feature, and actually, yeah, we'll do it this way. Okay, so since they're a good teammate, they have their own branch, which is Smarter Deposits. So they're working on this feature, origin Smarter Deposits. So they've been working on this. We can go ahead and investigate the source of the error here and just like quickly make that change. Close those here. Okay. So we can look at why this happens, and it's in minor. All right. I need to reopen Sublime, sorry. Sublime, okay. So again, so we're in left player, and we're looking at, stop that. We're looking at minor as soon as my computer loads, okay. Come on, minor. Okay, so we can see that the problem here is that the first thing that miners try to do is they try to refine the soup. So they try depositing soup, They try depositing soup before doing anything else, including mining. So all we need to do is just change the order of this. So they will always mine first, and if they are full of soup, then the mining will fail, and they will have enough cooldown to deposit. So this is exactly what we want. And we can just add a little comment here for our teammates. Mine first, then when full, deposit. Okay, so left person has made this change, which is great. They commit, mine, then refine. Miner, then refine. Okay, mine, then refine. And we'll pull, push. Okay, so great. So there's this new feature branch, Smarter Deposits, that left person has been working on. That's great. Right person needs these changes to effectively test the bigger wall changes, right? At least on the map infinity. So what can we do, right? Because left person hasn't merged this into master yet, and it's definitely not going to be merged onto this bigger wall branch, right? You're not going to submit a pull request from Smarter Deposit, the branch Smarter Deposits, to the branch bigger wall. You could, but that's a pretty slow way to do that. So what instead we can do, well, there are a couple of options. Left person, since this feature is done, left person could just like make a pull request, merge it into master, and it's actually going to work out the same way whether they merge it into master or merge it here or merge directly. And so what we'll do is we'll say, oh, okay, so we made some changes. Let's just go ahead and commit those. So we can say place dirt more often. Right, so we didn't test before committing, but we haven't pushed yet, so like we're not all bad. And what we really want to do is pull so that we can Git Checkout this Smarter Deposits branch and just make sure that we have the changes there. All right, so going back to what did I call it? Bigger wall. So going back to bigger wall, we now have the changes that left person made, but they're in a different branch. Fortunately, we can just git merge that branch. Git merge, what the heck is it called? Smarter Deposits. And so this will merge the changes from Smarter Deposits into our current branch. We'll make a merge commit as usual, and if we git lol now, we'll see that there's the branch Smarter Deposits, which has the mine then refine commit. There's the bigger wall branch, which is the one that we're currently on. And then there's master way back here before they diverged. And from the perspective of bigger wall, there was this one commit, and then there's this merge commit, which combines these two branches. So that's great. If left person looks at their history, they of course don't know about the bigger wall branch yet because we haven't pushed it. Well, they know about the branch, but they don't know about the changes yet. So all they see is that master is back here, and they have this one extra commit on a new branch. Meanwhile, right person knows about everything that's happened, and now can push to their bigger wall branch. Or I guess we should test it. Where's the client? So now we'll go ahead and we can see if, since the miners are going to get out of the way, we can better test this whole landscaper wall business. Maybe. Oh, no, we can't, because left person is in the way again. All right, well, pretend we tested it and pretend it works. It does work. I tested it earlier. But anyways, okay, so we tested it and it works, so that's great. So we want to merge it into master, right? Because we've made this feature. We, lecture player, have made the wall bigger, which is great. We want that to go into master as soon as possible so that we can like upload it to the scrims and increase our rank and all that good stuff. But we're in an interesting situation where now bigger wall is actually kind of two features, because we merged this smarter deposit stuff into bigger wall because we needed it. It was like a prerequisite to being able to test the changes that bigger wall made. So if we were to do a pull request for bigger wall, all of the changes that we have, including the ones that we merged from smarter deposits, are going to go into master. And usually you want to like sort of look at one feature at a time. So in a case like this, you want to be careful to make the PR for smarter deposits first. So, well, we can just do that. So you'd want to make the PR. Actually, I'll do the wrong thing just to show an example. So if we try to pull request bigger wall and we look at the changes, so we have the bigger wall change that we actually want to change, but then we have this other change which is totally unrelated to our feature, except that it was like a prereq, and we want to keep those separate. So instead, let's do the branch smarter deposits. And so this branch only has this one change, the moving that code block down here. So we'll PR this one first. And then once this one goes in, okay, so we'll delete. So now that this one has gone in, we can go and make a new pull request for bigger wall. And because bigger wall, the pull request is comparing bigger wall to master. So if we create a new PR now with bigger wall, this one, and now we look at the diff, it's only going to have the change we care about, because master already knows about this. Where'd it go? This one, this commit right here, mine then refine. That commit is now in master. So if we were to git pull, we can see that master is up here. This has gotten kind of messy because we took this commit, we independently merged it into this branch, and we merged it into master. So it's kind of hard to follow those lines, but this one goes up to here. And this one goes to master. So this is the state of the world right now. But that's why this diff only contains the place dirt more often commit, and it has this commit, which is no longer useful because it's already been merged. So now we can go ahead and merge this one in, and the team can look at this commit. The rest of the team is only seeing changes actually related to this feature because the other one went in first. So we'll create a pull request now that the other one is in, and go ahead and merge that in. One thing that we could have done, and I should have shown this before, is when you create a pull request, you can actually pull any branch into any other branch. So what we could have done is while we were waiting for, oh, I deleted the branch, so it's going to be a bad example. Let me just create a new branch real quick. Left person can do this. Git Checkout Master, Git Pull. We'll create a new branch, example, Git Push, origin, example. Okay, so now we have another branch that we can compare to. So say we were in the same situation, and we needed example to go in before bigger wall. So what we could do is we could put example into master. So we could create this pull request, and then we could create another pull request just for the sake of when your team looks at the changes, just so that they can see only the relevant changes. Or sorry, well, I did that wrong. Because bigger wall had the changes in example, which is meant to be the one we just deleted, smarter deposits, we could create this pull request. And in this pull request, we would see only the changes that are in bigger wall, but not in smarter deposits. So this is going to be that smaller diff where only the relevant changes are visible. Your team can look at these changes, see if they make sense, try to catch bugs, stuff like that. And then even after you create the PR, once the other branch gets merged in, you can just change this back to master, and then it will have the diff that you want. That is with only the features that are actually novel in this branch. That was somewhat convoluted, especially since the name of the branch changed. Does anyone have questions about that or what just happened there? All right, cool. Okay, anyways, so we've got all that stuff merged in. I can delete this branch now because that feature is done. And we are back to everything being on master and being clean. So we'll pull git branch -d example. And we can also delete the smarter deposits. So now if we git branch, we just have master on left person. If this person pulls, so we can check out master, we can get all that. And now the log looks like this. There was lots of stuff going on here, but now everything is back on master, and that's where we are also with head. So great, everything's been merged. We can delete the bigger wall branch, and now this one also needs to delete the smarter deposits branch because we had to download that to merge it. So now we have only master left. We have all of the changes and everything, and everyone is back in sync. All of the changes are in master, and we're good. There's just one thing, which is if we look at the log, there's a lot of merge commits in here. All this, there's more merge commits than actual changes, right? There's this merge bigger wall, merge smarter deposits into bigger wall, right? And then there's the two actual commits that we cared about, and then there's more merging, right? And this is kind of I don't know, half the history is just merges, which is all right. But if you are the kind of person that doesn't like that, then you have an option called rebase. So there's more than one change to combine two separate branches. And this graphic is the best way, in my opinion, to think about the difference between those. So with a merge, this is a frozen web page. Okay, this is what happens when you merge, right? So there's master, which may be different or something, and then there's your feature branch. And when you're on the feature branch and you say Git Merge Master, it creates a new commit, and it takes all of master's commits and puts them in your history. So this commit is going to say, okay, all of the commits behind it are in the history, and there's this new commit which says that and handles any conflicts and whatnot. And so that's what we have. We have lots of merge commits. The other way that you could consider combining two separate branches like this is to stack all of the new stuff on top of master. So in this case, you're taking all of the commits that you've already made. You're taking the new commits on master, and you're taking the changes that you made and you're putting it after the changes that were made on master. So this is going to create all new commits because the history is different, and like they're going to be different because it's the same diff, the same changes have happened, but it's starting from a different starting point, which is before it was starting at this node, and now it's starting at this node, this commit. So each circle is a commit, and the stars are new commits, just so that's clear. Right. So what you're doing is you're taking the diffs that you have, the changes and the additions and deletions, putting them on top of a different history. So this can lead to conflicts just like merging does, and you resolve them in the exact same way as when you resolve merge conflicts. If it can't do it automatically, then it puts all the little angle brackets and stuff and equal signs in your file, and you have to do it manually. But the advantage of this is that there's no merge commit. These changes have happened. These are your like feature related changes, and there's no merge commit. Also, the history is linear. So up when you merge, the history actually splits. Like the commits, there are two branches of commits, and they're totally separate from each other until you have the merge commit, which brings them back together. Right? This arrow is like actually a line that gets created in the graph, where like you see, like with this, you get all of this junk, right? Like lots of different lines and branches and things that split off from other things and go back into their original things and like all that craziness. That's what happens when you have lots of merges and like different histories and different people merging them together and stuff like that. Rebase is nice because it keeps the entire history linear. So this is really helpful for things like if you realize that you introduced a bug yesterday and you want to figure out which commit introduced the bug, you can start at like the commit now, which definitely has the bug, and the commit 2 days ago, which definitely doesn't have the bug, right? Or maybe 3 days ago or last week or whatever. And then you can binary search, right? Go to a commit in the middle, see if the bug is still there, right? And if it is, then go to a commit in the middle of that and the old one, see if the bug's still there. And that's a lot easier to do on a linear history than on a history that looks like this. So that's why some people like feel strongly about having a linear commit history, and that's when Rebase is useful. The problem with Rebase, and one of the things to be very careful about, is you are rewriting all of these commits. So you can never ever rebase something that someone else has already downloaded. You can like with when we were resetting stuff, we ran into all sorts of problems when left person had already downloaded the branch, had already pulled it, and we tried to rewrite history. It just didn't work, right? Or like we got into some annoying sort of situations. So you can't do this on branches that anyone else is using. And if you do it on a branch that you've already pushed to GitHub, then you're going to have to force push to overwrite the history on GitHub and replace it with all these 3 new commits that you've made during the rebase. So Rebase is something that's sort of like easier to mess up because you can get these like conflicting histories between you and someone else if they've downloaded it, or you and the remote. But it does lead to sort of much nicer commit history and fewer merge commits. So up to your team about what you care about more. I almost always merge instead of rebase, just because it's non-destructive. Like it's much harder for things to go wrong when you're merging than when you're rebasing. But it is a cool option if you want that. So I will show an example of that. But does anyone have any questions about how Rebase is supposed to work, or like how it's different from merging and stuff? Because this is not super clear. Like I had to learn how to Rebase like 5 times. All right, I'm going to do an example then. Okay, so let's go. Where's my to-do list here? Okay, so we're done with these. Okay, let's just do, since it's getting late, we'll just do we'll make good changes. Okay. All right, so left person is going to work on unburying the HQ, and right person is going to work on digging from a better location. So here's how we're going to do that. All right, so right person is going to, everyone is on master, they have the same history, so we'll do the usual thing, create a new branch. What did I say this person is? So like dig better. Okay, we'll push origin dig better. Okay, and then we just want to make a change to landscapers. So right now, landscapers, when they dig dirt, they just pick a random location and dig from there, which is like not necessarily optimal. You, in fact, maybe don't want to dig off of your own wall, for example. So we can just change landscapers to, instead of the try dig function doing a random direction, we can choose a direction that maybe is away from the HQ. So what we can do is we can say, well, first of all, we need a direction regardless. And if we don't know where the HQ is, then random will do. So if HQ lock is null, then what we'll do is we'll do that. So wait, that's not what I wanted. Dir equals this. Then we'll just choose a random direction. Else, the direction can be HQ lock dot direction to rc.getLocation. So this is the direction from the HQ to your location. So if you dig in that direction, you're digging away from the HQ, which is what we want. Okay, great. So now instead of just digging randomly, if we know where the HQ is, we'll dig in the opposite direction. So that way we should never dig on the wall. So great. Let's commit that. I should test it, but left person is messing up testing, so I'm not going to. And it's like a small change that I'm confident will work. So yeah, do as I say, not as I do. Okay. Right, so we're going to commit this. Dig away from HQ. We can push this to the dig better branch. Okay, so meanwhile, left person is working on their own feature, which is, what was it going to be? Oh, unburying the HQ. Very important. Save HQ. Okay. So origin, save HQ. All right, and so left person needs to edit landscaper also. And so the first thing that we want to do is instead of before even trying to, well, it doesn't matter if we do it. Yeah, we'll just do it first. All right, so the first most important thing for any landscaper to do is if first save HQ. Okay, so if the HQ lock does not equal null, so we know where it is, and we could say and hqlock.adjacent to, is it adjacent to or is adjacent to? I forget. Let's go to the spec. Nope, 2020 scrimmaging, getting started. Okay, where's the spec? Or the docs. Okay, so there's a function, an application function that tells you if you're adjacent to another location. So we'll do that. Where is it? Map location. Adjacent. Okay, it is adjacent to. Great, good thing I looked it up. Okay, so is adjacent to. And this takes another application, so rc.getLocation is my location. This is a tiny editor, but what this line is supposed to look like is that. So if the location isn't null and we're adjacent, then we should try to dig out from where the HQ is. So we need to check if we can dig dirt in the appropriate direction. We'll say direction dirt to HQ equals rc.getLocation.direction to. I should make sure I'm using that one right too. Direction to. Great. So direction to HQ lock. Then, if we can dig dirt in that direction, dirt to HQ lock. All right. So if we can dig dirt, then we do that. So that's the very first thing that we want to do. Okay, great. So left person has made this very important change. They'll want to commit it. Save HQ when possible. Okay, so they've pushed that. All right, and so now we have a couple of things. So say that left person's feature goes in first. So we'll do the usual pull request, save HQ. We'll create this. Our team will glance it over, make sure that it's sensible. Looking at the files changed. Maybe I shouldn't, well, that's too late. Okay, so right, these are the only changes. Looks good to me. Great. So we'll go back here and approve it. We'll merge that in. So actually, there are a couple of other, this is a good time to talk about the other options here. So you can merge, you can rebase and merge, which I'm going to do just as an example, and you can squash and merge. So squash and merge means take all of the commits on this branch, squash them into one mega commit, and then merge that in. And the reason that you'd want to do this is so that when you look at the commit history in master, and so this is like squash and merge is pretty much what everyone actually uses, like in industry and stuff. Because this way, when you look at the commit history of master, all of the commits are merge feature blah blah blah, merge feature blah blah blah, merge feature blah blah blah, then that's what it is. Also, this cuts down a lot on the size of the repo, because every commit is like a snapshot, right? It doesn't save all of the code. It saves it as diffs, so like differences between files. But it still saves like a lot of information over the course of many commits. So like the main Battlecode repo is over 4,000 commits, and that's one of the reasons that if you clone like the source code for Battlecode, it's a serious amount of stuff. Like it's pretty big. So that's another reason that companies especially will want to like squash and merge is that it keeps the repo size smaller as well. Because again, once a commit goes into master, you cannot rewrite it because everyone is pulling master all the time. And if you tried to rewrite master, it would just like be a disaster. So yeah, once something goes into master, it's in like the permanent history, which is why people will often squash and merge. There's another option, which is like less commonly used in my experience, but rebase and merge, which will just plop the commit. Instead of creating a merge commit in master, it'll take your commit and just like put it at the end of master. And if doing this would like cause conflicts or something, then this would not be a green check mark. It would be a yellow warning sign. But since this won't cause conflicts, GitHub is like, oh, yep, you'll be able to rebase this, no problem. So we can just go ahead and do so. Okay, great. And then we can delete this branch. And if we go and look at the commits now, we should see we just have that one commit that we added. So there's no merging pull requests, blah, blah, blah commit. We're just rebasing it right on top of master. And so that's like nice and clean. Okay, so great. If we wanted to, so say now that, left. So left person has done this thing. They're happy. They're going back to master. They're gonna pull their new change. They'll delete their branch. What was it called? Save HQ. Great. So now left person is happy. They did their commit. It's into master. They're gonna go to sleep for the day or whatever. Okay, but now lecture player is still on their dig better branch, and they have some changes. And so say we didn't want the messy merging silliness here that we had before. What lecture player can do is Git Checkout Master, so that we can make sure we have the most recent version, and then go back to their branch, which is dig better, and then Git Rebase Master. And so what this is doing is, well, it says exactly what it does. Rewinding head and then replaying your work on top of it. So we go back to master, and then every commit that we've made since we branched off of master, it creates a new commit with that exact diff, the exact changes to the same files, plops it right on top, takes the next commit, puts it on top, takes the next commit, puts it on top. And until our history has been completely rewritten. And so this is where master is. This is where the branch dig better is. And if we look at git lol, it's now, we now have a linear commit history. So this one right here is the origins view of the world. And that'll like cause us an issue or two in a second, which I'll show you. But as far as we're concerned, we have a linear commit history with master instead of having branches out here like we did last time. But we have this problem. So if we pull, so we'll just say git status first. It says your branch and origin have diverged. So you have 2 commits and origin has 1 commit that the other doesn't have. So if you use git pull, it will merge the remote into yours. So this is where rebases can get kind of messy. So if we actually pull, we're going to get a merge commit now. And if we look at where we are, so this just got a lot worse. So there's origin master, which is where we want it to be. Dig away from HQ, which is the commit that we rebased. So this is the one that we just made. But then there's another commit with the same message, dig away from HQ. That's the original commit that we made that was on GitHub. And so usually when you pull and GitHub has commits that you already made, it doesn't duplicate them, right? Because it's the same commit. But since we had to rewrite this commit in order to rebase it on top of master, as far as Git is concerned, these are 2 totally different commits. It doesn't matter that they have the same message. They're 2 different commits. So now they both have to be incorporated in the history, and the way that they're incorporated is with a merge commit, which is the whole thing we were trying to avoid, right? So now we need to reset that merge. We wanted to avoid this whole merging thing. So if we reset hard, we're back in the state that we were just in before. So this is how it was before. We have a nice linear history with master. Origin for this branch, the remote copy of this branch has our original commit that we rewrote that we don't want anymore. And Git status tells us that we have become mismatched with the remote branch. This is another time where you have to rewrite history. When you rebase, you have to rewrite. You are rewriting history, and so you have to force push to the remote branch. Since no one else has used this branch, that's okay. This is an example where it's okay to Git Push Force. Again, be very careful. We don't want to force push to the wrong branch because it will just delete everything on that branch and put our changes instead. We don't want to force push to master ever. We're going to force push just to dig better, which is okay because no one else has downloaded it. And again, this is one of the reasons that I personally prefer merging. It's slightly worse commit history, but it's so much harder to do something accidentally destructive. But I know people, so I personally use merges, but when I'm reviewing someone else's pull request and they've rebased off of master, reviewing those are so much better because the history after the fact is way cleaner. So it's way easier to look at their pull request and see what's going on and what's happened when they rebased. But as a person doing the changes, rebase can be more of a pain if you're not careful. So yeah. Anyways, if we look at the state of the world now, we can see that origin dig better, the remote copy of our branch, is now exactly where we are, which is what happens when you force push. And we have this nice linear commit history in the recent past. This is the commit that was made by left person, and then we have our commit made by lecture player. And even though we made those changes first, since we rebased on top of their changes, the new commit is newer, sorry. So this is a more recent commit. Even though the code was originally written earlier than left person, since we had to rewrite the commit, that just happened, so that's a newer commit than the save HQ one that left person did. Okay, great. So now we have this nice clean commit history. We've pushed it to the remote, and we could submit a pull request or something. Just as another example for rebasing, I think this is going to be the last example. Which one's lecture player? This one's lecture player. So if, for example, we had done save the HQ by trying to remove dirt from it. So if we did this and then we made a new commit that was add comments, add comments. And then we're oh, whoops, there's a typo. I'll just fix that. And then we make another commit which was typo. So this is what I actually did. Git commit typo. This is kind of silly, right? That entire commit is just a one character change, right? So if we look at the log, there's dig away from HQ, add comments, typo. The other thing that rebase can help you with is rewriting history. So I haven't pushed any of this yet, so it's going to be very, very nice and easy. There's a flag that you can use with rebase, -i, to make the rebase interactive. So far, I haven't used that, but it's actually pretty much always when you rebase, you want to use -i, which is why in the Git config, R is alias to rebase -i, because 99% of the time you want to do interactive, because it gives you a lot more visibility and control over what's happening. So if I say git rebase master, in this case, I want to edit the last two commits. So I'm going to go head ~2. What's cool is this now, before actually doing anything, you know what, to give a better example, how do I cancel this? Not remove, I just want to ignore these. If you remove, that commit will be lost. There's like a thing for ignore. All right, well, regardless. So the way that interactive works is before it actually does anything, it's going to say, okay, these are all of the commits that you're about to rewrite, or like that you may be rewriting during this rebase process. If you would like, you can decide more specifically what you want to do with them. So for example, you could edit the commit messages. You could, right, so the default is pick, which means like, oh yeah, take this commit, and when you're rebasing, add this commit to the end of the chain just as you normally would with a rebase. You can also drop it. So I'll just type it out. So drop is going to just entirely remove that commit. So if I did this, then it would pick the add comments commit, put that at the end, and then it would just ignore the typo commit. And then my new history would be, this is like the equivalent of if I reset hard head ~1. So I'm just dropping the last commit. This is exactly the same, just sort of a more roundabout way. I could also say, actually, I'd like to edit the code during this commit. Like I want to change the actual changes that happened during this commit. You can reword is if you want to keep it but change the commit message. So, embarrassing typo or something. Embarrassing typo. So like if I wanted to change the commit message. And then there's also like squash. So squash is going to, here, let me do this. So squash combines this commit with the previous one, which is probably what we want to do. But squash is also going to edit the commit message, and there's like a very small difference between squash and fixup. So fixup is the one right below here. Also, I never remember what any of these keywords are, so like it's helpful to do the interactive version that just tells you all of them right here. Anyway, so squash is going to merge the two and also merge the commit messages, whereas fixup is going to merge this into the previous commit, add comments, but just throw away the commit message. And so this is actually what we want to do. And so what we'll do is we'll say write quit, and when we write this file, that's going to say, all right, rebase, go, like execute this plan. So we're going back to commits in history, and then pick the add comments commit, slap that on the end, take the typo commit, and combine that with the add comments commit. So after we do this, our new history is going to look like this. So we have the dig away from HQ commit, which is where we rebased from. So that was the base. And then we have only the add comments commit. But if we look at the diff, so Git Diff also works. So you can if you just do Git Diff, it tells you the changes that you've made since the last commit. But you can also do Git Diff between two commits. So you can look at, for example, the changes from the last commit to this commit. And if we do that, then we can see that's the change that we made, and it now includes the contents of both commits. But there's only one commit message, all that good stuff. And so this is like a very, very useful use case for rebase, which is when you have lots of like tiny commits of like typos and whatever, you can squash or fix up a lot of those ones together. And then you end up with a much more meaningful commit history where it's like, it's very clear what I did. Dig away from HQ, add comments. That's it. Like you could even, in this case, the comment is so small, you may even want to like merge that comment, or not merge, sorry, I should be careful with my terminology. Squash that comment squash that commit with the previous commit because it's comments related to saving the HQ saving the HQ. I guess you would want to combine this one with this one, but regardless, we'll leave it like this. But the point is that you have a nice history, and yeah, so that's rebasing. It can be really nice, and since I haven't pushed yet, I can just push now, and there's nothing weird going on with remote having a different history and whatever because I rebased stuff that only I had, and that's when it's like really the nicest and most powerful, and like nicer even than merging often. But now we have a nice history. We can go back over here and create a new pull request for this last feature. And we can see the comment that we added and the actual content of digging better. So we'll create this pull request and we can just merge it in. Okay, so, I don't want to rebase and merge. Let's just squash and merge just for fun. And so what squash and merge will do is, so it's now, this is the new commit message, which is it takes this is the commit messages actually have two parts. The part that we've always been editing is sort of the like subject line of the commit message, but there's also sort of a body if you want to have like more stuff. So for example, if we look at git log here, these are just like normal commits and stuff. But then these commits, like this is the subject line, and then this is sort of more details about that commit. And GitHub does this automatically where it takes all of the commits in a PR and like when you squash or something like that, it takes all of the commits and puts them in sort of the like body of the commit, and then the subject line, which is the only thing that you see in git lol, is going to be the like name of the PR, which is the name of the feature, right? A very good summary of all of the commits. Presumably, the name of the title of the pull request is a summary of all of these commits. So that's why this is sort of the default behavior. You can edit it if you want, but I don't want to. Okay. Great. So now all of our changes are in master, and we can delete git branch, delete. Save it. Oh wait, we don't even have that branch. We were on a different branch. Dig better. Okay, so that's fine. And if we look at our branches, we just have master. And so we're back in the clean state. All the changes are in master. Everyone is up to date. All right, and now everyone is up to date. And that is a lot of Git stuff in 2 hours. So if you have any questions, I do want to emphasize the diff thing, just because that's super, super handy in case you missed it. Git diff is very powerful. You should use it all the time. On its own, shows you the changes since the last commit. You can also use it like this to see changes between two commits. You can also use it to see changes between two branches if you put branch names or something like that. So yeah, Git diff, very useful. All right, anyways, so that's a lot of Git stuff. I'm going to put this like very sort of brief summary of all the stuff that I said today in lecture player. Not the to-dos, but this stuff. I'll add Git diff because somehow I forgot to put that in here. All right, if no one has any questions, then that is all for today. And tomorrow will be the last lecture, Advanced Nav. All right. Bye, Twitch.